Pathogen recognition and tissue damage initiate an inflammatory response. Inflammation plays three essential roles in combating infection. The first is to deliver additional effector molecules and cells to sites of infection to augment the killing of invading microorganisms by the frontline macrophages. The second is to provide a physical barrier preventing the spread of infection. And the third is to promote the repair of injured tissue. Inflammation at the site of infection is initiated by the response of macrophages to pathogens. Inflammatory responses are operationally characterized by pain, redness, heat, and swelling at the site of an infection, reflecting three types of change in the local blood vessels. The first is an increase in vascular diameter, leading to increased local blood flow, hence the heat and redness, and a reduction in the velocity of blood flow, especially along the surfaces of small blood vessels. The second change is that the endothelial cells lining the blood vessel are activated to express adhesion molecules that promote the binding of circulating leukocytes. The combination of slowed blood flow and induced adhesion molecules allows leukocytes to attach to the endothelium and migrate into the tissues, a process known as extravasation. All these changes are initiated by the cytokines produced by activated macrophages. Once inflammation has begun, the first cells attracted to the site of infection are generally neutrophils. They are followed by monocytes, which differentiate into more tissue macrophages. In the later stages of inflammation, other leukocytes such as eosinophils and lymphocytes also enter the infected site. The third major change in the local blood vessels is an increase in vascular permeability. Instead of being tightly joined together, the endothelial cells lining the blood vessel walls become separated, leading to exit of fluid and proteins from the blood and their local accumulation in the tissue. This accounts for the swelling or edema and pain, as well as the accumulation of plasma proteins that aid in host defense. These changes are induced by a variety of inflammatory mediators released as a consequence of the recognition of pathogens. These include the lipid mediators of inflammation, prostaglandins, leukotrienes, and platelet activating factor, PAF, which are rapidly produced by macrophages through enzymatic pathways that degrade membrane phospholipids. Their actions are followed by those of the cytokines and chemokines that are synthesized and secreted by macrophages in response to pathogens. The cytokine tumor necrosis factor alpha, for example, is a potent activator of endothelial cells. If wounding has occurred, the injury to blood vessels immediately triggers two other protective enzyme cascades. The kinin system is an enzymatic cascade of plasma proteins that is triggered by tissue damage to produce several inflammatory mediators, including the vasoactive peptide bradykinin. This causes an increase in vascular permeability that promotes the influx of plasma proteins to the site of tissue injury. It also causes pain, which, although unpleasant to the victim, draws attention to the problem and leads to immobilization of the affected body part, which helps to limit the spread of any infectious agents. The coagulation system is another enzymatic cascade of plasma enzymes that is triggered following damage to blood vessels. This leads to the formation of a clot, which prevents any microorganisms from entering the bloodstream. Both these cascades have an important role in the inflammatory response to pathogens, even if wounding or gross tissue injury has not occurred, as they are also triggered by endothelial cell activation. Thus, within minutes of the penetration of tissues by a pathogen, the inflammatory response causes an influx of proteins and cells that will control the infection. It also forms a physical barrier to limit the spread of infection and makes the host fully aware of what is going on. And that's pathogen recognition and tissue damage initiate an inflammatory response. Have a great day.